Good morning, and thanks to the organizing committee for inviting me to give this talk. I think it might be a little misleading for me to tell you what the impact of the MCATs on chemistry is going to be, because really we don't have a great idea. We don't know exactly what those things are going to look like, in spite of what the Association of American Medical Colleges has told us. But with that as a kind of disclaimer, I want to talk about what we do know and the possible impacts that it will have on the whole chemistry environment. So many of you are aware of the fact that 3 years ago now, a little over 3 years ago, the Association of American Medical Colleges and the Howard Hughes Medical Institute Task Force on Scientific Foundations for Future Physicians put out a report, that's right there, that advocated a change in medical college admissions toward a focus on competencies. And furthermore, a change in medical education itself, medical college education itself, toward competencies, as opposed to pass this course, do this internship, etc. So this report plays into a change in the medical college admissions test that will occur in 2 years. In fact, part of it will be piloted next year for students taking the MCAT. So students who are in college now are going to be taking the MCATs that will be revamped. So let's talk a little bit about how they're going to be revamped, what they're going to look like. And the goal of what this revamping is, in fact, is to transform admissions into medical schools, to keep pace with changes in science and medical education, and to prepare physicians of the future so that they can improve the health of everybody. So that's the goal of the AAMC. So what's a competency? Well, you can define a competency as a combination of skills, abilities, and knowledge needed to perform a specific task. When you talk about a scientific competency in medical practice, it relates to patients. So what we're looking at is scientists, physicians, who have the knowledge, skills, and habits of mind to be able to understand scientific concepts, to understand discoveries, and to communicate them effectively to their patients. So communications, in terms of physician communication with patients, becomes a kind of a cornerstone of the new MCATs, in fact. How successful that's going to be remains to be seen, but that's one of their goals. The implications then for medical school admission is right here, the ability to demonstrate a core set of competencies needed to succeed in medical school and beyond. And so the AAMC HHMI report defined a whole set of scientific competencies, both for pre-medical students and medical students. We're not worried, well, we are worried, but we're not talking about medical school competencies. We're talking about pre-medical school competencies here, and particularly how they may end up affecting chemistry. In parallel with the Scientific Foundations for Future Physicians report 4 years ago, the AAMC has also produced a couple of other reports, one related to diversity, the other related, importantly, to behavioral and social science foundations for future physicians. And that is, again, among the competencies that they're looking at as they produce the new MCATs. So the new MCATs are going to have 4 sections with 4 different scores. And these are the 4 sections. Okay? The test is going to be 7.5 hours instead of its current 5.5 hours. It's not going to have a writing sample. That is currently in the MCATs. Probably just as good because we all know physicians don't know how to write anyway. So these 4 sections will be in there. You can see where chemistry is. I'm going to talk about that red box extensively. You can see here, though, where the section on the psychological, social, and biological foundations of behavior comes in. It's going to be a major part of the exam. And you've got that critical reasoning, critical analysis and reasoning section. What that is going to do is ask the examinees to critically analyze, evaluate, and apply information that is given to them on the test from the humanities and social sciences to solve problems in ethics, philosophy, etc. And specific disciplinary knowledge will not be needed. That's a part of the exam to assess how people think. Okay, so that's not going to have a chemical basis at all. The 8 major competencies for medical students that will be looked at in the MCAT are these. The 2 in yellow are obviously related to chemistry and biochemistry. Number 2 right here is certainly related to chemistry, but not necessarily content. So really 4 and 5 are the ones that really are the ones that, as chemists and chemical educators, we have to be concerned with. So, for example, that part of that competency has learning objectives. Those learning objectives include demonstrating knowledge of atomic structure, of molecular structure, of intermolecular and other molecular interactions, knowing something about the effect of thermodynamics on physical and chemical processes, and demonstrating knowledge of chemistry of carbon-containing compounds relative to their behavior in aqueous environment. It's interesting, as part of this exercise, the AAMC surveyed a lot of senior medical students, last year medical students, as well as new physicians, about what in chemistry was important to them. One of the highest ranking pieces of information of importance was organophosphorus chemistry. Okay, to an organic chemist, organophosphorus chemistry says Wittig reagents, and that's not what they meant. They meant phosphate esters. They didn't ask the question right. Phosphate esters is not something that's taught in chemistry very much, and yet that's related to chemistry in water, especially organic chemistry in water, and that's the type of thing that they're talking about in aqueous environments. What the plan is to ask questions at the intersection of content and skills, and I'm not going to go into the skill types of things that they're talking about. They've delineated 4 different types of skills that pre-med students will have to demonstrate, and what they're going to do is try to ask questions at the intersection of the skill and competency kind of roadmap. So again, going back to this red box, the chemical and physical foundations of biological systems. Foundational concept number 5, as they've defined it, is the principles that govern chemical interactions and reactions form the basis of a broader understanding of what goes on in living systems. That's going to be a box that they're going to be asking questions on. And I think all of us would agree that's an important competency for students going into medical school to be able to grasp. For that section, that red section, they will test introductory level biology, organic and inorganic chemistry, and physics. So that doesn't change from what it is now. Biochemistry concepts that are taught usually in a one-semester biochemistry course, so we're not talking about very esoteric kinds of biochemistry questions, but certainly biochemistry will have a focus in the MCATs. Cellular and molecular biology, basic research methods and statistics, and I guess I really like that. I want my physician to understand the importance of statistical power of clinical testing. Of course, the scientific inquiry and reasoning and research methods, etc. What they say at this point, and this is subject to change, the tests that are still being written, obviously, but the approximate distribution of questions in that section will be 30% general chemistry, 25% organic, 15% biochemistry, a quarter physics, and then 5% of the chemistry kinds of and physical science kinds of things that might be presented in a biology course. I don't see this as gigantically different from what we have now, maybe with a little more biochemistry. But this is what they're telling us at this point the test will look like. The question then becomes, if we're worried about competencies, and we should be, what's the best way to make sure that students who are taking chemistry with the designs of going to medical school can develop these competencies in an interdisciplinary kind of context? And there are two possible approaches. You can apply the concepts of chemistry to biological examples in biology, or you can apply the biological types of knowledge or context to chemical principles in chemistry courses. Or should you do both? Well, probably you should do both pedagogically. But since we're worried about chemistry, it makes sense that as we teach chemistry at the fairly introductory level, general and organic, we should be doing some connections to biology as much as possible. The trend has been in that direction. It probably needs to continue in that direction. So, should the chemistry curriculum change because of the MCATs? Currently, it's a pretty standard approach that students take a year of general chemistry, unless they waive out of it, take a year of organic, and at least the savvy students make sure they take biochemistry, either a semester or a year. Some schools require biochemistry at this point, some don't. But it's not obvious that this has to change. Okay, I don't see any reason necessarily that a school or a program has to make a change in what they teach pre-meds. However, there are opportunities that are presented by this publication, the Scientific Foundations of Future Physicians, and there are also some challenges that it brings up. So let me talk briefly about the opportunities and the challenges. I think almost everybody in this room who teaches freshman and sophomore chemistry students will agree that the majority of them have a biological leaning. Okay, they're either pre-meds or pre-pharmacy. We have a ton of pre-pharmacy students at the University of Cincinnati, almost as many as pre-meds, or pre-vet or pre-dental, or just biology students, a lot of them. So it makes sense to introduce more biological examples throughout chemistry courses, especially in general and organic chemistry. The other thing is Anne McCoy talked earlier about the 2008 guidelines for undergraduate professional education in chemistry, which allows a lot of flexibility in how you design your foundation courses. You don't have to necessarily teach a biochemistry course, for example. You have to have students have the equivalent of a semester's worth of biochemistry in order to meet the requirements of a certified degree. You don't necessarily have to teach them an organic chemistry course, per se. They have to learn the equivalent of at least a semester's worth of organic chemistry. So there are a lot of opportunities there to modify curricula. And obviously, that can be taken advantage of when you consider the needs of biologically oriented students. So there are five, there is a task force within the ACS on this issue, formed as a subset of the Committee on Professional Training and the Society Committee on Education, which we have done a lot of searching at what is already being done and what's planned to be done in the curriculum of the first couple years for pre-meds and others of that ilk. There are basically five different approaches that have been taken or can be taken, at least five that we've identified, to meet the opportunities that are set up by this report from the AMC. All of these approaches assume that there will be a biochemistry course, or at least the equivalent of a biochemistry course, thrown in. So the traditional approach, not doing very much different from what goes on now, what I would urge people to do and what a lot of programs are doing is not changing anything. They're looking at the MCATs and saying, I don't need to change anything, but it makes sense to integrate biological examples wherever possible into the curriculum. So that would include things like talking about enzymatic catalysis when you talk about other types of catalysis, including the role of proximity within active sites and non-bonding interactions. Okay, that's chemistry, but it's got a biological slant. Talking about peptide bonds and protein conformations when you get to carboxylic acid derivatives, rather than waiting till chapter 27 of the organic text to talk about those topics. Throw them in where they belong, which is when you talk about amide bonds. Same thing with talking about saccharide. When you talk about the formation of acetals, you can talk about sugars. You can talk about converting hydroxyl groups to biological leaving groups like sulfates or phosphates, which will occur in water. You can throw in biologically relevant types of reactions in addition to the standard synthetic reactions, like, for example, the Claisen condensation to form acetoacetyl-CoA as being a very, very important biological reaction. That's a Claisen reaction. It comes in the carbonyl chapter, chapter 19 of our text, okay? Second possible approach is to have a first semester of organic where you introduce most of the major concepts, including carbonyl chemistry and functional group chemistry, some spectroscopy. And then in the second semester, offer a choice of two courses. Offer one that is really a bioorganic course, and then another one that's more mechanism and synthesis, which could be for chemistry majors or chemical engineers or whoever else is taking organic chemistry. Oberlin College has been doing this for 20 years very successfully. It obviously depends on the availability of teaching resources to have two different second semester organic courses, but it seems to work really well at Oberlin. And other places are doing it as well. Haverford is doing a similar kind of approach. The HHMI has funded Mark Loudon at Purdue University to develop a 2-year chemistry curriculum, which is a 1-2-1 approach. 1 semester of general chemistry, 2 of organic, 1 of biochemistry, which is tied closely to the SFFP competencies, where general chemistry has a strong connection to biochemistry. The organic course that he is devising de-emphasizes things like retrosynthesis and organometallics and places a much heavier emphasis on mechanisms with biochemical implications. This, of course, assumes that freshmen can get by with 1 semester of general chemistry, but they also have a kind of a remediation approach for students who need to do a little chemistry before they get into this 1-2-1 approach. So this is an approach that several schools are looking at, and Purdue is converting this to most of their chemistry tracks at this point. There are schools that have successfully taught organic chemistry as a freshman course. It's not a typical organic course. It's not taking second-year organic and turning it into a freshman course. But it starts with regular general chemistry principles, but does them in an organic context, and then teaches organic chemistry. And this has been done very successfully at Juniata College in Pennsylvania for many years, where they then follow it with a couple of semesters of more traditional chemistry. They have their chemistry majors take another organic chemistry course in their junior year to kind of finish up the kinds of things that they didn't get to in their freshman year. But that's another possible approach. The perhaps most radical approach that's being looked at is at the College of St. Benedict, St. John's University, which is the female-male pair in Minnesota, where they have totally scrubbed their first 2 years of chemistry. And they have now created a semester of what they call structure and properties, and then 3 semesters of reactivity 1, 2, and 3, where they integrate structure and reactivity in the context of organic, inorganic, and biochemistry throughout 2 years of the curriculum. And they are making a big effort to link this course with the competencies that the MCATs will hopefully measure. This course is certainly allowed by the CPT ACS guidelines, but it hasn't been reviewed yet. I've heard a couple of talks on it. It sounds very good. It takes a lot of work. It takes a lot of coordination, but that is probably a more extreme approach to meeting what the new MCATs are going to be looking for. Lots of challenges, though. Smaller schools probably don't have as much flexibility at doing some of these things. It's going to probably be tougher to meet the needs of all their students. Curricular change, especially if you're going to revamp your curriculum completely, takes a lot of buy-in from not only the full chemistry faculty, but coordination with the biology department and whomever else is impacted by this. There's also the probable issue in some cases of the availability of appropriate text. That can be a problem. And in fact, CPT actually several years ago, when we started thinking about this, had discussions with textbook publishers. And their issue is that they're not going to write textbooks until they know there's a large enough audience. So in a lot of cases, there won't be a large enough audience until they're textbooks. So we're kind of stuck. But that's an issue. We talked briefly before about articulation between 2- and 4-year colleges. If you have a modified curriculum and somebody wants to transfer in, where do they fit? That can be an issue. There's also the possible issue if you go to 1 semester, for example, of general chemistry, what happens with the need for TA support at a large school? So there are challenges by all of this, but there are, as I said, opportunities as well. So there are a lot of unanswered questions. Will medical schools have the ability and the desire to adjust their admissions requirements to do away with course requirements and reflect competencies almost completely? That remains to be seen. Will undergraduate programs be motivated to map courses onto pre-medical competencies? Will, in fact, the new MCATs successfully assess competencies with what they say is going to be credibility and reliability? That remains to be seen. And will the MCATs follow up on what people have been saying, minimizing the emphasis on organic chemistry and especially non-biologically relevant chemistry? I've got my doubts. For example, in their guide that they published on studying for the new MCATs in 2015, they say that they may test Grignard reagents. Okay, how many physicians care about Grignard reagents? Or the preparation of mesolates and tosylates to convert hydroxyl groups to leaving groups. Yeah, that's great if you're working in toluene. or any organic solvent. It's not going to work when you're working in water. You go to phosphates and sulfates. So I'm not convinced that the MCATs are going to change as dramatically as people are afraid they might. But we'll see. One other thing I want to mention. A year ago, in the Journal of the American Society of Biochemistry and Molecular Biology, Charles Brenner and Dagmar Renge wrote a comment, I guess it was, recommending that pre-medical students only need a year of chemistry and a year of biochemistry to learn everything they need to learn. And they said as an intermediate step, it might be okay to do the 1-2-1 thing. But they're urging a year of chemistry, including general and organic and some inorganic chemistry, and then a year of biochemistry. I reject that out of hand. I don't think that you can possibly do students a service by going to that model. But in fact, sometime in the next several months, there will be a series of commentaries in the Journal of Chemical Education, including one by Charles Brenner, that will talk about this whole chemistry in the pre-medical curriculum subject. So that should be an interesting thing to see. I'm guessing maybe July or August, but I'm not sure exactly when that's going to be published. So the bottom line is that we need to see how the MCATs are constructed, how they treat the intersection of content and skills in chemistry, and then figure out what our metrics ought to be so that we know that pedagogical changes, any pedagogical changes that are made will be meeting the needs not only of the pre-medical students but all students. So with that, thank you very much, and hopefully we have a couple of minutes for questions.